Mixed numbers. How do we convert mixed numbers? First, mixed numbers are whole numbers with a proper fraction added to them. So what would we want to convert them to? What are mixed numbers? What do they represent? Well, mixed numbers represent how many wholes of something that we have, whereas we can convert them to improper fractions, which name the number of parts of something that we have. Now we remember for mixed numbers, we have a whole number and a proper fraction, meaning the number here in the denominator tells us how many parts we needed to make a whole, and that's why we were able to remove the whole. Here in an improper fraction, we have a greater number of parts here. This represents the total number of parts we have in the problem versus the denominator of how many we need. So if we wanted to move between the two, do you think we could convert between proper fractions, improper fractions, and mixed fractions? The answer is absolutely yes. And the easiest ones to convert between are mixed fractions and improper fractions. Now, the way that we're going to do this is we are going to take that whole number value, which is being added to a proper fraction, and we're going to draw this out first. We're going to take that denominator and multiply it by that whole number. So whatever you like to use to represent multiplication, that is the first step. Take that denominator and multiply it to that whole number, and then whatever answer we get there, we are going to add that numerator to it. All right, all of this that we're doing here goes in the position of the numerator, and then we're just going to scooch that denominator right on over. So let's look at how this would look here. We take that denominator, and we are going to multiply it by our whole number, and then we're going to add the numerator to that, and then in the denominator position of this fraction, we are going to leave that denominator. That is how we're going to convert mixed numbers to improper fractions. All right. Adding mixed fractions with like denominators. There are two ways that we are able to add mixed fractions with like denominators. So for example, if we have a mixed fraction with a numerator and a denominator being added to another mixed fraction with a numerator and a denominator, let's highlight these pieces first. So here we see that we have our whole numbers, and that's going to be in the green there. We can add those whole numbers together. Whole number of that first fraction plus the whole number of that second fraction. Then we can go through and add the proper fractions together as well. So here I'm highlighting our proper fractions in blue. We're just going to add those here. And we have the numerator and the denominator of the first fraction plus the numerator over the denominator of the second fraction. All right, and we're just adding those together. Now remember, we have an unwritten invisible addition symbol between our whole number and our proper fraction. So in this problem, we're also going to have an invisible addition symbol as well. All right. That's the first way that we can add mixed fractions with like denominators. Another way that we can do that is by converting them to improper fractions first. So in order to convert them to improper fractions, we take that denominator, multiply it by that whole number, and then add it to that numerator. So here we can have the denominator times that whole number plus the numerator all over the denominator, plus for the second fraction, the denominator times that whole number plus the numerator all over the denominator. And then once we get that, we simply add our proper, or whichever type of fraction that we get, we add our fractions together. All right, that may seem like a bit much, but let's practice that. Let's do this one together. We got this. So the first thing that we're going to do is we're going to do it the first way, where we're going to add the whole numbers together and then add the proper fractions together. So let's identify those. Here we have a whole number of 4. Here we have a whole number of 1. We know that we're just going to add those together, 4 plus 1. Then we're going to go to our proper fractions. We have here in our first one, 4/7, and here we have 1/7. So we're going to add those two together here, and we're going to put 4/7 plus 1/7. All right. As we go through that, let's continue. 4/7 and 1/7 are common denominators, so we absolutely know how to add those. Starting with our whole numbers, 4 plus 1 is 5. 4/7 plus 1/7 is 5/7. Very simply. All right. That is the first way. Let's now try the second way. The second way means we take these whole fractions and we convert them to improper fractions, or these mixed fractions which have a whole number and proper fraction to improper fractions, right? We take 7 times 4 plus 4. All right, 7 times 4 plus 4. and then we write that all over 7. Then we're going to add that to 7 times 1 plus 1. 7 times 1 plus 1, all over our denominator of 7. So 7 times 4 here is 28. 28 plus 4 is 32. So we have 32 sevenths. Here, 7 times 1 is 7, plus 1 is 8. So we're adding 8 sevenths to that. 32 sevenths plus 8 sevenths is 40 over 7, because we know we add common denominators. We add the numerator straight across. How many 7s can we take out of that? Well, 7 times 5 is 35. So if I subtracted 35 from that, that means I pulled out 5 wholes to make this 35 here. And when I pulled that from there, that left me with 5 sevenths, which is here. So it is the exact same thing. You get the exact same answer. It just really depends on how you would like to work out this problem. All right, go ahead and pause the video, and I want you to try to do the check for understanding, and I'll be right back with you to see if we share thinking. All right, welcome back. Let's try this check for understanding. Now we remember, when we want to add mixed fractions with like denominators, there are 2 ways that we can do that. We can simply add the whole number component together first, and then we can add the proper fraction component together, or we can convert both of our mixed fractions to improper fractions. Here we go. Step 1, whole numbers give us 7 plus 1, which we know to be 8. Our proper fractions, 2/9 and 4/9, give us 2/9 plus 4/9. We know we add those numerators together. 2 plus 4 is 6/9. Both of those can be simplified by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So that means we still drop down that whole number component, and our answer is 8 2/3. All right, give yourself a pat on the back if that is what you got. Let's try it again using the improper fraction method. If you tried it this way, let's see what you were thinking. I am thinking I'm going to draw little arrows here. It helps me to cement my thinking. So 7 times 9, or 9 times 7 plus 2. That reminds me what to write. 9 times 7 plus 2. And we keep our denominator exactly the same. Then for the second one, I'm going to draw my arrows as well. 9 times 1 plus 4. Here, 9 times 1 plus 4. Keep that denominator 9 exactly the same. And look, I put denominator instead of 9, so let's change that to a 9. All right, let's work this out. 9 times 7 is 63. 63 plus 2 is 65. So this first one gives us 65 ninths. That is way more than 9, so I know that's going to give me a bunch of whole numbers. Here, I have 9 times 1, which is 9. 9 plus 4 is 13, so that also is greater than 9. That's going to give me a few whole numbers as well. So let's just add those together. 65 plus 13 is 78 over 9. I know that 9 times 8 is 72. So if I subtracted that 72 here, which I know is worth 8, and let me write that just a little clearer. 72, which is 9 worth, so 9 times 8 is 72, and I subtract that, I know that that's going to leave me with 6 over 9, but I do want to point out that this 72 here is my whole number that I took out, because 9 times 8 is 72, so I took out 72 parts, which gave me 8 wholes. That's why I took that out there, and that left me over 6/9 here, and I know that I can simplify that once again just by simplifying by a factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So my answer here again is 8 2/3. It just depends on how you want to work that problem out. All right, we have learned 2 different ways to add fractions with like denominators. The first way that you can do that is to simply add the whole number components together and then add the proper fractions together using the like denominator method that we have practiced. And the second way is to do a multiplication, addition, conversion to improper fractions. All right, if you feel like you can add mixed fractions with like denominators, go ahead and give that box a check. Happy learning.